We all know that training modern AI models requires massive amounts of data, but there's a hidden tax: massive labeling costs and the time spent training on redundant images. But what if you could prune 90% of your data set before you ever spend a cent on labels or a millisecond on training? Hi, my name is Brent Griffin, and today I'm presenting ZCore, a method for state-of-the-art Coreset selection that requires absolutely zero labels and no training on candidate data. So why do we need this? Consider applications like robotics or autonomous driving. These systems are data-rich but label poor. Every hour a robot operates, it generates a massive stream of visual information, envisioned here literally as a data dragon. The problem is we can't possibly label all that data. Nonetheless, existing state-of-the-art Coreset methods require you to spend a fortune on manual annotation or compute-heavy self-supervision, just to find those hidden gems in your data. But this is a fundamental paradox. To save resources, those methods require you to first spend those resources. This makes them unusable for the massive data streams generated by robots and autonomous vehicles. This is the bottleneck of modern AI development. We're drowning in data, but starving for the right subset to train on. Now let's look at the actual bottlenecks that stop us from taming that dragon. Most existing methods have a massive entry fee. Labeled methods like TDDS require you to label everything first. Self-supervised methods like ELFS skip the labels but require extensive pre-training time. Thankfully, ZCore is different. As you can see here, we are the only state-of-the-art method that requires zero labels and no candidate data training. It's fast, parallelizable, and it's the only approach that maintains high generalization across data sets and prune rates. So how exactly does ZCore achieve these results? Let's walk through the ZCore pipeline. We begin on the left with our raw, unlabeled data stream. Instead of expensive labeling, we use off-the-shelf foundation models to project these images into a high-dimensional embedding space. Our core innovation is the iterative subspace sampling loop. We first slice embeddings into smaller, manageable subspaces. We then sample these subspaces to mathematically score every image, and we unify submodular coverage rewards and redundancy penalties into a single objective that's solved across all subspaces. As you can see in the value map, we identify and prune the redundant low-value data, the yellow points, and prioritize the high-value data, the purple points, that provide the best coverage for your model's specific training budget. Let's look at what ZCore actually selects. On top, we have the good. These are the high-value images selected for the Coreset. Notice the incredible diversity. We have aerial shots, everyday objects, and distinct textures. ZCore identifies these as critical for capturing the full data distribution. Conversely, on the bottom, we have the bad. These are images ZCore correctly identified as redundant and then pruned. Look at the armor of the repeating aerial patterns. They offer almost no new information to a training model. By removing these bad examples, we dramatically reduce training costs without sacrificing accuracy. Finally, let's talk about the ugly, the runtime and annotation cost comparison with top-performing methods. As you can see from our benchmarks, ZCore isn't just a little faster, it's in a league of its own. We are 28 times faster than TDDS on a standard laptop and 40 times faster than ELFS on a GPU. But the most important number is at the bottom, 10 times fewer labels. By operating at a 90% prune rate on ImageNet, we effectively remove the need to annotate over 1 million images. But this speed and efficiency doesn't matter if you lose accuracy. So let's talk about performance. Here, we compare ZCore against a wide array of state-of-the-art methods. The orange arrows emphasize the most challenging but rewarding scenario, the low data regime. Here, ZCore consistently maintains higher accuracy than all methods but TDDS, which requires labels and training on the full candidate dataset. Notably, at a 90% prune rate on ImageNet, ZCore achieves the best overall performance. We're effectively beating the competition while using 1.2 million fewer labels. This confirms that ZCore isn't just faster. It's a better way to find the images that actually drive model performance. So yes, in ZCore's case, you can have your cake and eat it too. To wrap things up, ZCore is a new state-of-the-art Coreset selection method that requires zero labels and no training on your candidate data. It's built for speed, running over 28 times faster on a standard laptop than previous methods, and it easily scales from CFAR to ImageNet. ZCore is also fully open source, so you can scan the QR code here or visit our GitHub repo and start taming your own data dragons today. Let us know how it goes, and thank you for watching.